Hello! Yes! And welcome back to our Objective 15 notes. This is part 2 of Objective 15, which I'll remind you is I can solve a system of linear equations by graphing and determine if two linear functions have one solution, infinite solutions, or no solution. And that's what we're going to focus on today, this idea of one solution, infinite solutions, or no solutions. So if you recall, in part 1, we reviewed graphing. We talked about what a system of equation was, and we talked about how to find a solution. Remember, we graph them together on a coordinate plane, and the solution is where they intersect. But with letter D here, we found what happens if they don't intersect. Well, if the solution is where they intersect and they don't intersect, that means that there's no solution. Alright, so let's break it down a little further, really delve into this idea. So there's three possibilities for the number of solutions in systems of linear equations. First, it's possible that there's one solution, and that means the lines intersect at a point on the graph. Alright, and if that's the case, there's one solution. Then it's possible for there to be no solutions, and that's what we had up above, right, with letter D. Now, no solutions occur if the lines have the same slope but different y-intercepts. Alright, and we would call these lines parallel lines, in that they have the same slope, so they'll never intersect each other. They are parallel. Looking at letter D up above, notice how they both had the same slope of 2, but one had a y-intercept of 4 and the other one had a y-intercept of -2. So they will never intersect, which means that they have no solution. They're parallel lines. The third option is if the equations represent the same line, which means that when I graph them, they intersect an infinite number of times. And that's only possible if the line has the same slope and the same y-intercept. Now, when we show this graphically, it's going to look like there's only one line on the graph because both of those equations represent those same line. So looking here, we can see letter A, same slope, different y-intercepts. This is an example of no solutions. Letter B, two lines intersecting at one point. That's an example of one solution. And letter C, it looks like there's only one line. Now, since this is a system, we know there's multiple equations, but multiple equations expressed by one line means that there are infinite solutions, right? Because any point on that line will make both equations true. All right, so let's dive into it. Let's do some examples. Let's look at letter A here. X plus 2y equals 6. 3x minus 2y equals 2. Well, let's do this top one here. So x plus 2y equals 6. Let's get it in slope-intercept form. Subtract x, so I'd have 2y is -x plus 6. Divide by 2, divide by 2. And I'll have y equals -1/2 x plus 3. So -1/2 x plus 3, y-intercept of 3, slope of -1/2. So I'd go down 1, right 2, down 1, right 2, down 1, right 2, up 1, left 2, up 1, left 2, up 1, left 2. There we go. Connect the dots. Beautiful. There's our line there. Now let's try this bottom equation here. 3x minus 2y equals 2. So I'm going to subtract 3x from both sides. We're going to get y all by itself here. So -3x plus 2, divide by -2, divide by -2. Remember, a negative divided by a negative gives me positive, so this will be positive 3/2 x minus 1. So I'm at -1 for my y-intercept, and then I'll go up 3, right 2, up 3, right 2, down 3, left 2. That's going to be all we can fit. Connect my dots. Beautiful. All right. So looking at this, one solution, no solution, or infinite solutions. Well, the lines intersect at one point. All right. This one point right here is the coordinate point 2, 2. So this is one solution, and that one solution is the coordinate point 2, 2. One solution. Beautiful. All right, let's try another one together. 3x minus y equals 4 and y equals 3x minus 4. All right, let's do this top one, get y all by itself. So 3x minus y equals 4. I'm going to subtract 3x from both sides. That tells me that negative y is negative 3x plus 4. When I divide by negative 1, I'll get y equals now positive 3x minus 4. So y-intercept of negative 4, a slope of 3. So up 3, right 1, up 3, right 1, up 3, right 1. Connect my dots. Yes. Beautiful. And that's my first. Oh, look at my second equation. Y equals 3x minus 4. Well, do we notice how these have the same slope and the same y-intercept? All right. Same slope, same y-intercept. Infinite solutions, right? If those lines have the same slope and the same y-intercept, right? Because if we graph both of these, it'd be the same graph. So all I'd have to say now, infinite solutions. Because any point on this line that I graphed is going to be true for both of these equations because both equations represent the same line. All right. Why don't you try letter C on your own? Go ahead and try letter C on your own. Pause the video. Try letter C. We'll see how we do. All right? All right. Let's check out letter C here. Well, y equals negative x plus 1 is already in slope-intercept form. So plus 1, and then y in down 1 over 1, down 1 over 1 with that negative 1 slope. And I can connect my dots like so. Should be a pretty straight line with all these dots. Not bad. Not bad at all. All right, y equals 3. Now remember, horizontal line is y equals. So y equals 3 would just be this line right here. All right, well, one intersection point. So one solution, that's the point negative 2, 3. Negative 2, comma 3. And that is indeed one solution. Excellent. All right, if you had any struggles on C, raise your hand, let me know, and I'll come around and check. Otherwise, why don't you go ahead and try letter D on your own now, all right? Go ahead and try letter D, see how we do. Letter D on your own, go ahead and pause the video, give D a shot. All right, let's check out letter D here. So this first equation's in standard form. Let's get it in slope-intercept. So negative 2x plus 3y equals negative 6. I'm going to get y all by itself, add 2x to both sides. When I do that, I get 3y equals 2x minus 6, divide by 3, divide by 3. So y would equal 2/3 x minus 2. All right. So let's graph this. 2/3 x minus 2, y-intercept of negative 2. 2/3 would tell me up 2, right 3, up 2, right 3, down 2, left 3, down 2, left 3. And I can connect my dots. Beautiful. All right, there's one. And then notice, oh, look at the second equation. Y equals 2/3 x plus 3. So plus 3 means I start here, and then I do that same slope of up 2, left 3. So what type of lines are we going to have here? We're going to have parallel lines. Interesting. Well, what do we know about parallel lines? Are they ever going to cross? No. Therefore, is there going to be a solution? No. What does that mean? No solution. And again, we can tell that by seeing that these lines have the same slope, 2/3, but different y-intercept. One of them's positive 3, one of them's negative 2. So we know confidently that letter D here is no solution. All right, page turn. Why don't you try letter E and letter F on your own? Go ahead and do both E and F on your own, and then we'll check them together. All right, go ahead and knock out E and F. All right, let's check how we did on E and F. So looking at letter E, we're in standard form, so let's get it in slope-intercept form. I'm going to subtract x, and that tells me that y equals negative x plus 2. So my y-intercept is 2, my slope is down 1, right 1. That negative x, plotting those points. Beautiful. Up 1 over 1. Yes, yes, yes. Connect the dots. Gorgeous. Alright, now looking at the second equation, 7x plus y is negative 4. So I'm going to start by subtracting 7x. When I do that, I get y equals negative 7x minus 4. And that's all I really need to do there. Negative 7x minus 4, so my y-intercept is negative 4. Now that would say down 7, right 1, but I can't fit that. So let's go up 7, left 1, and that'll put me there. That's going to be the only points I can really fit here. This is going to be a super steep line. Wow, that's awful. Let's try it again. A super steep line. There we go. Much better. And I can see there's one intersection point. That is the point negative 1, 3. Which means that there is indeed one solution. Fantastic. All right. Let's check out letter F here. 5x plus 2y equals negative 6. 5x plus 2y equals 4. Now, if you're looking here, you can probably guess what this is going to be. All right, this is going to be no solution because I know I'm going to get the same slope out of these, but these are different numbers. So let's see how that works out here. So I start with 5x plus 2y equals negative 6. It's not in slope-intercept form, so let's get it that way. Subtract 5x from both sides, so I'm going to have 2y equals negative 5x minus 6. Divide by 2, divide by 2. I get y is negative 5 halves x minus 3. So negative 3 is my y-intercept. Down 5, right 2, or up 5, left 2. Put me right there. Connect my dots like so. Beautiful. All right, now 5x plus 2y equals 4 in my second equation here. So I'm going to start by subtracting 5x from both sides. When I do that, I get 2y equals negative 5x plus 4. And then when I divide by 2 to get y all by itself, y is negative 5 halves x plus 2. So 2 here, and then I'd go down 5, right 2. That'll give me something that looks like this. Interesting. So, parallel lines never going to cross, just like we guessed at the beginning. This is indeed no solution. These lines will never intersect. All right, hopefully we're feeling pretty confident. If you have any questions, let me know. Otherwise, why don't you finish up by doing letters G and H on your own. Go ahead and knock out letter G and letter H. Go ahead and pause the video, give them a shot, and then when you're done, resume, and we'll see how we did. All right, let's see how we did for letter G and letter H. So first, looking at letter G, I see x equals negative 4. Well, that's a vertical line at negative 4. So I can just graph that real quick. And then my second equation, y equals negative 1/4 x plus 1. So y-intercept of 1, and then a slope that would tell me to go down 1, right 4, or up 1, left 4. And I can see in this case I'm going to have one solution. Let me go ahead and finish graphing my line. Remember to graph that line all the way. Make sure you that's showing your work here. And my solution is negative 4, 2. And as I said earlier, there is one solution. All right, last one, letter H. Negative x plus 4y equals 8, and y equals 1/4 x plus 2. So let's start by getting this first equation in slope-intercept form. So I'm going to add x to both sides. So I'll have 4y equals x plus 8. Divide by 4, divide everything by 4. So y will be 1/4 x plus 2. Now notice here, y equals 1/4 x plus 2, y equals 1/4 x plus 2. This is going to be infinite solutions. However, we can't stop there. We need to actually graph that line to show our work. Alright, so we know it's infinite solutions. Let's show it by graphing y equals 1/4 x plus 2. So plus 2 is right there. We'll go up 1, right 4, down 1, left 4. And we can connect the dots. And boom. We got it. All right. If you have any questions, please feel free to raise your hand. Otherwise, this is Mr. Carter signing off. I'll see you next time.